All right, so let's talk about a little more modular arithmetic, and here you hit important stuff, but it's a little mind-bending. So if you find it confusing, have patience, you'll get used to it, and you'll keep running into it until you get used to it, just like all these things. All right, so here we can talk, there's something, we've done modular arithmetic before. If you're on a ring, you can take numbers, and you can add numbers, and you can subtract numbers. You can even multiply by things. I can take 1 times 3, and it'll get me to 3. If I take 3 times 3 again, I take another 3 and another 3, I get to 0. Because that's 9, and 9 mod 9 is 0. So you can do addition, multiplication, and subtraction. But you cannot do division. There is no such thing. You want to take 1 and divide it in half, you get a half. It's not on the ring. There's no way to put it on the ring. There is no division in modular arithmetic, which is, of course, a huge problem. Because if you're going to encrypt something, you would like to decrypt it. You encrypt things with a multiplication operation. You'd like to decrypt them somehow. What you do is you multiply them by another number, which is the multiplicative inverse. You can't divide, but you can multiply it by another number that undoes the previous multiplication, which is why I say it's a little mind-bending. It's something that does not happen in linear number lines. It happens on rings. So here we got modulus 9. If I take 2 times 9, mod 9, I can take the 2 and the 9 and take the modulus separately. The second one is 0, so I will get 0. 2 times 10 mod 9 is 2 mod 9 times 10 mod 9. 10 mod 9 is 1, so it's 2. So you can do this. You can apply the modulus to the product, or you can apply the modulus to the individual terms. All right, so 2 times 9 mod 9 is 0, and 2 times 10 mod 9 is 2. Now notice this, 2 times 10 is 2. So 5 is the modular inverse of 2. If you multiply 2 times 5 mod 9, you get 1. That's 10. Okay, so you've now found 2 numbers, which when multiplied give you 1. That means if you multiply something by 2 and then multiply that by 5, you'll get back where you started. This is what you would normally think of as division. If you need something to multiply 2 by to get 1, you'd normally like to say 1/2. But in modular arithmetic, you have to find the modular inverse, which is 5, and you're just going to have to try numbers until you find it, although there is an algorithm that's ancient that does help track it down. But it is not obvious at all that the way to undo a multiplication by 2 is to multiply by 5, but it's true. And so if you were to encode data by multiplying it by 2, you would decode it by multiplying it again by 5, which is how it actually works for a bunch of encryption based on this, like RSA encryption. All right. So here's mod 9. If I take 6 times various numbers, and notice 6 does not have a modular inverse. If I keep multiplying 6 times 1, 6 times 2, 6 times 3, 6 times 4, I just go 630, 630, 630. I explore various answers, but I never get 1. There is no number that is the inverse of 6. This is an important fact to know. Some numbers do not have a multiplicative inverse. And this comes back if you get into cryptography, like RSA cryptography. There are certain numbers you cannot use for the encoding key, because if you do, it will destroy information and there is no way to decode it, which is one of the many problems with RSA encryption is based on this system. So let's try 7. If you multiply 7 times 1, you get 7. 7 times 2 is 14. That's 5 mod 9. 7 times 3 is 21. That's 18 plus 3, and 7 times 4 is 28, which is 27 plus 1. So there, by an exhaustive search, we have found the multiplicative inverse of 7. It's 4. And there's no simple pattern, no easy way to get here.
So
yeah.
6 and 9 cannot be the keys, or the...
That's right. If you multiply by 6, you destroy information. Originally, you had 9 possible values. Now you only have 3 possible values, so there's no going back. There's no way these 3 possible values could have encoded all the information in those 9 possible values. So that's an issue. Multiplying on a ring does not necessarily preserve information. It can destroy it.
Yeah.
And anything that destroys information, you cannot reverse.
As far as I can tell, anything that either, so like 3, 6, and 9 all have the same tree, pretty much.
Yeah, well, the fundamental point is if this has a common divisor with that, then you will destroy information.
Yeah.
And that's why the safest thing is to use prime numbers here, which can never have however, in RSA encryption, unfortunately, you actually have to choose the product of two primes here, and that means there's a whole bunch of numbers. All the products of the fundamental primes are numbers you have to avoid, numbers that will destroy information. Yeah,
so
good.
Like if you have 17 times 3 is 51.
Right.
So you can't have 3 or 17 as the encryption key, but you can have any other number that isn't a multiple.
That's right. That's exactly right. Yep. So if you have a number up here, if your modulus is the product of two primes, you have to exclude all multiples of both those two primes. And that's why they call it Cauchy's number or something. It'll come back to me. If two primes are P and Q, an essential number is P minus 1 times Q minus 1. That is the number of actual numbers you can use. Those are the numbers that don't hit each of those problems. Exactly. Good. All right, so let's try modulus 4. If here's why modulus 4 works, right? 0 is 0, 3 is 3, 4 is 0, 5 is 1 again. So 12 is mod 4 and 13 like this. You see how it goes. All right, so let's try some Kahoots about this. Or rather, some of these things. See how these work. All right. There we are. So 8 times 2 mod 4. What do you think? 0, right? Because 8 mod 4 is 0, so it doesn't matter what the other one is. The first term gives you 0, so the answer is 0. How about 8 times 2 mod 5?
1.
Yes, because 8 mod 5 is 3, 3 times 2 is 6, and that's 5 plus 1. That means that 2 is the multiplicative inverse of 8. Multiply anything by 8, and then multiply that by 2, you'll get back where you started. How about 5 times 4 mod 9? I don't think so.
5 mod 9 is 5, right?
Yes, 5 mod 9 is 5.
So
16 is not,
it would be 2. It would be 2.
it's 2.
Because 5 times 4, they stay the same.
Right,
So it's
see?
20.
Right.
20 divided by 9, remainder is 2.
Exactly. 20 is 18 plus 2, so the answer is 2. This is 20. That's 2 9s plus 2. Let me check and see if there's comments coming in the Twitch. Nothing. All right. We'll go here. All right, so that's 2. All right, what's the multiplicative inverse of 3 mod 4? Now this one will be a little bit of work. Well, in fact, I got it. There aren't that many choices, so.
4. So that leaves 3. So to get to 1, you'd need to multiply. I don't think you can.
You can.
You can? Okay.
Although that's an option, there is none.
What does multiplicative inverse mean?
That means if you multiply 3 times this, you'll get 1.
Yeah.
Just what the inverse typically means.
So
It's just
4 is 3. To get to 1, you need to get 1 more than 4 as the total. So you
1 more
need
than a
to
multiple of
get
4.
5 or a multiple of 4 plus 1, so 9.
Right.
So 3. So the multiplicative inverse of 3 would be 3.
Exactly. 3 is its own inverse. If you multiply something by 3, and then you multiply it by 3 again, you're multiplying by 1, because 3 times 3 is 9, which is 8 plus 1. So in this case, the encryption key and the decryption key are the same.
So it's
Just like XOR, if you just repeat the encryption process, it will undo the previous encryption process in this case.
So
Yeah.
3, but also, how exactly, I haven't been able to figure out how to turn these ones in.
Oh.
Is it like a screenshot or something?
No, you'll end up with a flag here, and you can just put it in the scoreboard.
Oh.
After you get a number of them right, a flag will appear down here. But you have to get a number right, either 5 or 10 right in a row. I modeled it after the Khan Academy, where that's what they do.
Okay,
Yeah.
I got like 4 in a row, got 1 wrong, kept going, and I kept getting 1 wrong every so
Right, right. You have to get a certain number right in a row.
I didn't realize it was a certain number in a row.
Yeah, exactly.
Because
That's it.
The number of correct just kept going up anyway, despite getting 1 wrong.
Oh, well, that's just a defect in my scripting then,
Okay.
which is possible. By the way, if you like web hacking, they're easy to cheat. In fact, I had one of these students point out you could cheat, and I said, that's great. So I made another game that was effectively impossible to try to encourage people to cheat. Made people get like 200 right, and I taught a room full of college professors, and they were all doing 200. And I'm like, no, no, no. The purpose of that is not to make you do 200. The purpose of that is to make you rebel and start cheating. Because it's real easy to cheat on these web-based games.
Yeah.
Anyway, but that's web hacking, which is technically a different topic.
I saw a YouTube video explaining how to use the edit thing in the HTML
Yeah.
for the dinosaur game to make your character invincible.
Absolutely. And you can do a lot of that. You can do it with Android games too. Yeah. Anyway, so the inverse of 3 is 3. Let's do another one of these. How about the inverse of 4 mod 10? Ah.
I don't think is there a way to do this? I
No.
don't think there is, because mod 10 doesn't.
That's right, there can't be, because this is a multiple of 2 and this is a multiple of 2. And that means you're just going to get even numbers. You'll never get a 1.
Yeah.
If they have a factor in common, there is no inverse.
Okay, so yeah.
All right, so the answer is there's none. All right, and I guess you have to get 10 right to get the, let's do a few more of these then. 8 times 3 mod 9.
8 times 3.
Okay,
So it'd be 8 times 3 is 18, so that's a 0. Or no, 8 times 3 is 24.
right.
6.
24 is 18 plus 6. I'm with you. I like 6. Let me see if there's anything coming in the Twitch. Okay, nothing there. All right. I like 6. How about 8 times 2 mod 7? That's easy.
That's 16, so 2. That's
Okay, it's also 7. 8 mod 7 is 1.
1.
So it's 2.
1 times 2.
1 times is 2.
Oh, it's still 2.
Yeah, 1 times 2 is 2. Yeah.
1 times 2 is 2. Okay.
Yeah. All right, the multiplicative inverse of 4 mod 15.
So there's no conflictions. 2 compared to 3 and 5. So that's easy, it's 4.
That's right, it's 4 again.
4
4 times 4 is 16, which is 1. All right, I'll do one more and that'll be it for this stuff. 12 times 1 mod 11.
1 times 1 is 1.
1 times 1 is 1. All right, good. Let's check the Twitch. All right, well, that's all I wanted to show you about that. Let me stop this recording.